it's to say the least humbling to be here today, partly because I will talk about so-called unusual collaboration, and this is what the work that I will present now. But what most of you will not know for sure is that I don't think that I would have ever been in this room studying consciousness had it not been for Stan. And when we're in the Collège de France, it's interesting because I was in Chile. I was the only PhD with a closed EEG that I had to open up to try to understand what consciousness was. And I came across his paper. And for years, he was my only teacher, literally. So to me, this is extremely humbling because he has been teaching generations through generations, but also he taught this small girl in many kilometers, just through his beautiful papers. And I always tell my students, if you want to learn cognitive neuroscience, open up any of his books, open up any of his papers, and you will know how to do good science. So, okay, this is just to say, I don't have a picture of that moment because it was in a basement in Chile, right? So, but what I do have is a picture of what to me was this incredible human singularity, which I would actually perhaps say Stan singularity, of being able to tell us everything about numbers, then tell us everything about consciousness, then tell us everything about reading and writing, and then go on with education, and then now on seeing the mind. I don't know any scientist that is capable of doing that. And I think that a lot of the people who have been today in this room are incredible scientists, don't get me wrong. But this is a human singularity. And when you are in front of a human singularity, you also ask yourself what it is to create, what it actually means to create for somebody. And I will, in this presentation, I will only talk about the work of consciousness. But when I was thinking about Stan, I was thinking about something like this. There's a global phenomena called Taylor Swift, and she's capable of actually moving masses. We are all here today. We came from everywhere in the world. And I know that everybody who got this invitation, I think that the first speaker actually mentioned this, would have come even if this is in a basement. This is global masses that you're capable of moving. But also global masses that he's capable of touching with his incredible talent of telling us about learning, language, memory. There's so many talks that I could give about Stan, and this is just just to tell you that, like Taylor Swift, who every year reinvents herself, I don't know in which era of Stan we are, to be honest. This is one of the things that is really hard to predict. And Nama yesterday, so Taylor Swift likes Easter eggs. Nama yesterday put this number there. And of course you would say, well, of course it's 12 times 5, 60. Sure. But it's also a very important date for somebody here. So this is just all to say that when I started studying consciousness, I started not from a, oftentimes people come to this field from more, how shall I say, like theoretical point of view. I came across this because as I was studying my PhD and I was obsessed with the unconscious, I received a phone call and I was told that the partner of my sister at the time was in the hospital and he was 19 years old at the time. And, you look at this person, it moves, it's full with, machines. And somebody tells you, well, this person, and it moves literally, it doesn't move normally, but, it moves, right? And then somebody tells you, this person is brain dead. Do you want to donate the organs? And it's like, well, the scientist says, yeah, of course. And then the person says, what? And then you are left with this feeling of, is there somebody in there, right? And that night, I am a lucid dreamer, and I wrestled that night with that particular moment. And I thought, this is interesting. So he was in the hospital moving. I am here in my bed, immobile, fully there. But if somebody sees us, how is somebody going to know who of us is there? And then click. And I realized that is the problem of consciousness. How are we going to find that out, right? And ever since, that has been my quest. It's not only to try to find a theory, but what Lionel actually showed yesterday, go from the theory, not to the classroom, but from the theory to the clinic, as they have also done, right? Because this has clear consequences. And I know that understanding consciousness is complicated and is very, sometimes controversial. But when you are in a hospital room, it's not controversial anymore. You just want to know, period. It's just very simple. So what did I learn that night? That consciousness is experience that might not necessarily transfer on behavior. I can be there in my full dreams, but you might not know anything about it. And that is private. I know that I have it, and I can measure it for myself. I think this is what Stan and Lionel call access, or I can have a report for myself. I know that I'm conscious, right? And I don't need any measurement. I know it, right? For a fact, I know now that I'm conscious. I don't know about you, but I'm pretty sure about myself. Now, as a scientist, we are in this dilemma. So how am I going to know what is the consciousness of someone else, right? And we oftentimes resort to just asking, or do more complicated tricks these days. We do brain readings, but whatever we do, we somehow need to actually get from somebody else this internal experience, which is not all that easy. And when I was studying, and when I had that moment in the hospital, I thought, okay, my God, this is just hopeless. How are we going to really know whether this person is there, right? And this is actually when I came across this model, and I'm so grateful for Jean-Pierre for actually having presented before, because it somewhat gave, at least back to me, it gave me the impression that this was trackable. We could do something with this. This is just not something that is very abstract. No, we can actually measure it. There are neurons in there. They are these phonoeconomal neurons. They have long axons. They're in layer 2, 3. So it seems that it was not just this spooky problem, right? But it was something that we could actually go and investigate. But at the same time, it was full with at that time, philosophy, right? So it felt like Taylor Swift, like this, and that's why I call it yellow, fearless, because this person who really wanted to tackle a problem that most people would have just run away, right? And this is just to give you a sense of, ever since, this is, 1998, when the, model kind of starts, and you can see how it's taken over the years, so these really mark my generation of scientists, which actually came to understand that we could study consciousness, we could measure it, and it was just not spooky. And I think this is all thanks to, you giving us a substance that we could actually look at. This is, through the, beautiful work, that Jean-Pierre was referring now. My favorite paper was this one. This one was the one that I was reading when I got the phone call. And I thought, and if you have not read it, this is one of my most elegant. I think that this, you have done many, many papers, but this to me remains one of the most elegant ones. And then Stan showed us that you could even measure it, as I said. So it was not just theory. You could actually, put somebody in the scanner, and you would actually get fronto-parietal activity, as they had predicted. Right? And then Claire, I'm sure that she's going to give you the latest updates on all of the things that they have been doing. And then back to 2001, you can see here that we even had Stan gave us a compendium with some people here in the audience already providing chapters for that. So it seemed at that moment that it was something that we could study, right? Fast forwarding 20 years, then we did now a meta-analysis of what has been the impact of global neural workspace. And by and large, it has been the most influential, by numbers, the most influential theory in the field. This is, a meta-analysis that we did with Liad and Itai Yaron. And in blue, you see how many papers have supported the claims of global neural workspace, and in red, how many papers have challenged global neural workspace. And as you can see, there's actually very few that have challenged it, and many more that have supported it. Now, what happened during those 20 years was something a little bit paradoxical somewhat. Because not only Stan's model was around, but also other models actually came along. The recurrent processing, integrated information theory, higher order theories, and and as you can see, by numbers, they're actually far less influential, right? That's correct. But what seemed somewhat interesting is how if we have had 25 years of devoted research, why have we not converged into a better understanding as opposed to have this divergence of ideas, right? And you would imagine, or at least this is what I would have imagined, that ideas, the most influential ones will prevail and the ones that are less important will die out, right? But if you break this over the years, you will see that all of them somewhat gain support here. This is divided by support, and very few gain challenges, right? So that, I think, is symptomatic, not of the theory, but of the field, right? So to say the least, there is very limited crosstalk between these theories, and either we are not measuring the same, or we are explaining different phenomena, or what have you, but the fact that there are so many, it's symptomatic of us as a field. Now, what was also interesting is that if you put all of the findings from those 25 years together, you end up with almost the entire brain lighting up, which is also, like, we have not ruled out. So Luca told us something about negation and, counterfactuals. I would have thought that, there's some parts we have ruled out. Apparently, we didn't, right? But this is not true if we now look by theory by theory. If you look at, for instance, recurrent processing, you would say that every time you only looked from that theory, the areas that they tend to associate with consciousness is only the back of the brain, right? And if you look at a global workspace, it's mostly fronto-parietal networks. So there is somewhat like a theory bias here as well, right? So we are finding more or less what the theory somewhat says. What was also interesting, like from this meta-analysis, is that you could predict which theory it was based on the methodological choices that those theories made. So what that means is that we are not studying we're not using the same paradigms to study this phenomenon. So we're using certain paradigms for theory 1, certain paradigms for theory 2, and so on and so forth. So it becomes very difficult to compare them on the same ground, because every theory tend to, perhaps for theoretical reasons, tend to have its own paradigms. So, after those 25 years, instead of actually having one model, we had at least a handful of 4, right? And in thinking about that, the question became, so can we think of ways in which we can bring all of these fields together and somewhat try to measure them on the same rule, right? So not on different paradigms, but on the same paradigm. And Danny Kahneman, he had actually come up with this idea of adversarial collaborations. Why had he come up with this idea of adversarial collaborations? Because he realized that otherwise we do a lot of parallel play. We publish in different journals, or people tend to become nasty. They do what he called like angry science. So he thought that this was a good way of trying to avoid angry science and try to resolve, rationally speaking, with your enemy, quote unquote, your divergences, because ultimately we all want to know, right? So it's not that we have in opposition. I just want to give you here a little bit of an intro to what Danny was thinking about, because they are not easy.
Not to win. You have to be willing to accept a draw, and to see that in the interest of science and and civility and other things, a draw is better than a win. I happen to find a few people who are willing to do that. By the way, it is not easy, because people who think poorly of your work and of your ideas get on your nerves, and so you have to overcome that.
So you can imagine that, they oftentimes they look nicer in paper than in reality. And in paper, how do they look? There is something interesting. So the idea of an adversarial collaboration is that you have a true collaboration, which means that you allow for the divergence of voices. So you look at the same data, but you may actually have different interpretations. And this is very valuable because, the ways in which we look at the data is also characteristic or tell us something about how we're going to look for the next experiments as well, right? And how we're going to, modify the theories and so on and so forth. So therefore, like the allowing for having interjections is really important in this kind of collaborations. So back in 2018, we met at the Allen Institute. Beautiful place, it was a very interesting, 2 days meeting. And here I want to start because why I have put emphasis today, not on my work, but on, like Stan's work, so to speak, is because one of the things that makes scientists remarkable is not only that they are productively, incredible like him, but also the virtues that they have. And that's something that oftentimes we don't talk enough in science. The virtue of being open, the virtue of being bold to collaborate, the virtue of being courageous. I can tell you that we started with 3 people in that meeting, but we ended up with only 2. Now, this is just to tell you that not everybody's cut the same way. This requires that you really want to, stick out your neck in ways that, like other people will not want, right? So this is yet another chapeau for you for the kind of model that you are giving to us as a scientist. Okay, now, there's this paradox about adversarial collaborations. When are they most feasible but least useful? When you're in epistemic heaven. What does that mean? That you have testable theories, agreement on the test, respectful disagreements. You can also be in the so-called epistemic hell, which is when you have no clear criteria for falsification, disagreements on methodological issues, no agreed test, fractioning into opposing camps. So I thought that hopefully we will be in the murky middle, neither in one way nor the other, and that's how these adversarial collaborations actually started. So which ones are the theories that we were testing? Integrated information theory and global Workspace theory. I will put more emphasis on Stan because, for obvious reasons, I think that we are now celebrating him and not, integrated information theory. But this is just all to tell you that they make somewhat different commitments in terms of biological principles. So Stan really thinks that there is a fronto-parietal network that is relevant, whereas for your theory, the frontal areas are not necessary. And that's perhaps like the most important thing. One theory is much more rooted, it is rooted in cognitive neuroscience and in cognitive psychology. The other one is mostly rooted in phenomenology. So they actually have a number of significant differences, right? We nonetheless thought, okay, let's just try to put them together. Was that easy? No, but we thought at least we need to try to make them to converge. And we came up with 2 different experiments, one which we call the Mona Lisa, I will tell you later on, which tries to look for the necessity of the mechanisms for consciousness. And what do I mean by that? We ask 2 questions. So what mechanisms underlie the rich experience of consciousness and without like having any enrollment of the task? And what are the mechanisms that explain the maintenance of the experience? And I will explain you later on what I mean by that. And in this case, we presented stimuli that were full visible. And that's why we're only testing for the necessity of the mechanism, but not for the sufficiency. Right? So the fact that the mechanism is there doesn't really tell us that it is necessarily, that it is sufficient. We have a second experiment, which I will not tell you right now, but you will see later on where it becomes relevant, with which test for seen versus unseen, and that actually tests for the sufficiency of the mechanisms, right? And that's why it's important for us, when we set up this collaboration, that these 2 tests needed to be together, right? Because one without the other does not test for necessary and sufficiency, right? Okay, so what was important is that we made very clear predictions beforehand, very clear tests that we were going to have, and it took us almost a year to come up with the whole pre-registration, with the experiments, the theoretical outcomes, the interpretations, the predictions, and so on and so forth, right? And after that, COVID kicked in. I will not tell you it was hell that time because we needed to collect data all across the world, and we thought that this was impossible, but we managed. So we'll tell you now the success story, so to speak. So what is the first experiment about? We collect the Mona Lisa, which I think is interesting because we are now in Paris. And to give you the intuition is we are trying to understand the richness of the experience. And when you think about Mona Lisa, the first thing you think about is, well, it's a woman, and it's a human and not a cat. So you immediately have the concept of a category when you see her. You also know that it's Mona Lisa and not any other person. So you immediately have the sense of an identity. You also know that it has an orientation. The Mona Lisa wouldn't be the same if it's looking somewhere else, right? And if you keep looking at the Mona Lisa, the assumption was that you will continue seeing it. right? So all of those aspects, category, orientation, identity, and stability, were aspects of our conscious perception that we tried to capture with this experiment. And the idea was that the theories needed to explain how in the brain these contents of our experience are actually present. We are scientists, so we are not, like Da Vinci, so we use this kind of stimuli, of course. So we have different categories, in this case, like faces, objects, letters, and phones. We have 20 different identities for each of those. We have 3 different orientations, and we presented the stimuli for different durations, right? Importantly, what we needed to do is to also remove the effect or the confound of the task. So in some of the cases, we were presenting these stimuli at different durations, and the subjects would only focus on 2 categories at a time, and the others were category irrelevant. And then we'd switch the task, and then the other 2 stimuli will become now relevant for the task, and the other ones would be irrelevant. So then we could remove the effect of task, right? So with that, then we went into the brain. So now the question was, can we now try and answer 2 questions in which these theories did make divergent predictions? One is about what are the mechanisms underlying this rich aspect of conscious perception and the maintenance. So we collected fMRI in 120 subjects, EMG in 102 subjects, and ECOG in 34 subjects. Why? Because we know that each of these techniques has pros and cons. And we really wanted to get an answer as good as we could, in principle. And we had 3 predictions based on the postulates of the theory, so the contents of consciousness, so where in the brain we are supposed to have content related to consciousness. The second one is, what are the mechanisms by which we maintain a percept over time? And the last one was, what are the networks that are engaged and in which is the form of communication? And let me just start with prediction number 1. As you may have seen now from the work from Lionel and the work from Jean-Pierre, of course, for global workspace, the fronto-parietal network makes a significant contribution. Therefore, all of the contents of consciousness should be present in frontal areas, as well as in parietal areas and in cingulate areas. But for this collaboration, we focus only in the frontal, not because it's a frontal theory, very, very important clarification, but just because it was different from the other theory, right? That's the only reason why we focus on the frontal areas. Now, for the other theory, the most important part, in terms of, hosting the correlates of consciousness is areas in the back of the brain, and that's why we could actually have the divergent predictions. Now, we also asked Stan and Julie in this case to tell us, where in the brain we should be looking for this, right? So they gave us, ROIs or regions of interest in which we would actually look for these signatures. And the first prediction was to look for where is information about the category of the stimuli and the orientation of the stimuli hosted. And what you're seeing here, this is the responses of fMRI. This is decoding, and this is cross-task decoding. This is work inspired by the beautiful work of decoding that Jean-Remy has done. So what you can see here is there is the very beautiful decoding in frontal areas whenever we have houses versus faces in this case, right? Or objects versus faces. And we can replicate exactly the same without, this is just the virtue of the data, that in ECOG we see exactly the same responses in exactly the same areas, right? So based on that, we would say, we actually have very good evidence that prefrontal cortex does contain information about content, category in this case. Now, but what about orientation? When we looked at now, can we decode the orientation of the stimuli? We couldn't actually find any information, neither in fMRI nor in ECOG. But we did find information about orientation in EMG. We downweighted because we couldn't convince ourselves that it was not a problem with the technique. So in this case, we would actually be capturing responses from posterior areas. But this is just all to say that yes, we don't find information with some of the techniques, but we do find it with some others, right? And this actually posed the question of, is this a problem with not having the orientation information from the cortex, or instead the techniques that we are using? All right, so prediction number 2, very important. As I mentioned before, we are manipulating the time at which we present this stimuli. And Stan back in the day said if the subjects are conscious of the onset and the offset, they should actually have an ignition at the beginning, an ignition at the end of the stimulus, right? And therefore, if the stimuli are present for a longer time, then we should actually find an offset that would scale with the length of the stimulus, because that's the time at which the offset occur, right? The other theory made a different prediction. In this case, it was a sustained response, as opposed to just an onset or an offset, right? And in terms of representational similarity or information content, in this case, the idea was that in the case of GNW, we would see responses at the very beginning that code for the stimuli that the subject is seeing, and also at the very end when it's the offset. Whereas for the other theory, it would always be sustained, right? I will only show you the responses, the data we got from ECOG. What you can see is the beautiful responses in. First of all, what you can see in green is the areas in which we looked for electrodes that would have an onset response in prefrontal cortex. And we found out of 500 electrodes, 99 that already have these onset responses, right? So that's a fairly prominent response there. Now, what we did not find was electrodes that would have an offset response. We only found one, but it was earlier than what Stan had predicted, right? Now, when we looked at representational similarity, we again found very nice decode, in this case, representational similarity for category at the onset of the experience, so in light with ignition, but not at the offset. And this was also not present for identity. So you would say, based on this, that GNW is challenged based on that. We also didn't find either responses or decoding at the level of the offset. When we looked at decoding, in this case, it's not only when we look at representational similarity. So it does, methodologically, it doesn't seem to be there. Finally, the last prediction was for Stan, or for global workspace theory, is very important to have the fronto-parietal networks in consonance with, in this case, associative areas, right? So and this is supposed to be done through synchrony. Right? So we look in this case for synchronization that would mark the ignition responses between prefrontal cortex and high-level visual areas. And importantly for Stan, this is a phasic response, whereas for your theory, it's a sustained response. And it should only be between B1 and high-level visual areas. So what did we find? Both consistent evidence from fMRI in this case, when we do psychophysiological interactions between, in this case, FFA. We recover, in fact, the frontoparietal network, IPS, and prefrontal cortex. So there is connectivity in this case. When we do the same analysis with ECOG, we also recover frontal areas. And what you can see here, this is the time frequency responses that actually show that there is a very nice ignition response in this case, in the frequency in which Stan had predicted. So based on that, we would say, and importantly, we did not find the pattern that IAT had predicted, which in this case was a sustained response between B1 and FFA. So where does that all leave us? And I think that it leaves us with, we do have fairly good evidence for ignition. I hope that you could actually see it. We do have evidence for global broadcasting, with a caveat. In this case, we did not find information about orientation, right? So that actually, could it be a problem with us, with the experiment? We will discuss it later on. We also didn't find any responses at the offset, right? But we did find, as Stan had predicted, very nice long-range synchrony, which is actually very difficult to obtain. So I think that this was also reassuring for us. And as I told you, we had this paper at 3 voices. So now I want to bring Stan, because this is something that, unfortunately, nature didn't allow us to have this in the discussion. So I want to make sure that now it is in the discussion now. So he raised a number of issues, but one of those, and I will actually go through some of them here. So the first one is, it's impossible to decide which of the activations reflected conscious versus non-conscious processing because the experimental design did not contrast a conscious versus non-conscious condition. Absolutely. He's absolutely right, and that's why we have the second experiment. So that one's easy to answer, so to speak, or hopefully we will get the answer. The next one, Stan rightfully say, well, prefrontal cortex responses are hard to decode from the macro or mesoscopic signals measured by fMRI, EMG, or large intracranial electrodes that pull over tens of thousands of neurons. Absolutely. And that's why I'm super excited, because Lionel and others are doing exactly the same experiment now in mice, and in monkeys with causal manipulations and with actually single units recording. So we will now have the level of precision, hopefully, to then answer this in a much better way. But I do think that he raised here a very important methodological caveat that I want to actually go over, which is that this experiment, I will quote him first and then we can discuss this. The present experiment relied on the seemingly innocuous hypothesis that stimuli were indubitably consciously experienced. Why? Because we presented them on the screen one at a time. So you would say, yes, absolutely. For their entire duration. However, this is well known that perfectly visible stimuli, depending on attention orientation, may fail to be seen, like in attentional blink, Claire has shown that, in attentional blindness, or may become conscious at a time decoupled from a stimulus presentation, like in the psychological refractory period. Here it seems likely that subjects briefly gain awareness to all the images, since they remembered them later on. This is a control experiment that we have, but they reoriented their conscious thought to other topics, without waiting for the image offset, and this interpretation perfectly fits the ignition profile that was found in PFC. Fairly reasonable, right? And I think that I kind of have to agree with him, because we did some experiments back in the day with Rafi Malach, where we had actually shown something different, which is that whenever you blink, your sensory stimulus is completely gone. And yet, your consciousness is there. So we also do know that there is a huge decoupling between, what the external world shows us and what we actually perceived. And we could demonstrate that high-level visual areas do not register this lack of sensory stimulation. So I cannot more than agree with him. So what we did next was to actually follow up, right? And he had actually given us this beautiful idea that, okay, there's the psychological refractory period, which is the idea that if you have one content in consciousness, or in this case in your attention, if you have another task, it will collide. And the second one will actually be delayed until the first one is done. And so now he actually had this brilliant idea of using the psychological refractory period as a way to measure whether or not the subjects were conscious or the global workspace was occupied at the onset as well as at the offset of the experiment. Why? Because we didn't want to ask them. Because if we asked them, then of course we actually have a task, right? So the idea here was to do it in an indirect way. And what Alex did was to now, in this case, present tones at different timings at the onset and at different timings at the offset for different durations of the stimuli, right? And here the subjects, what they had to do was to only concentrate on the tone. This was the task that they had to give the response time, right? But the hypothesis was that if the global workspace is occupied, we will nonetheless see a delay in the responses, even though they are not doing a task in and of itself. It is just that the global workspace is occupied. And we use exactly this because we wanted to actually link this to the results that we had before. We use exactly the same stimuli as in the first experiment. And the predictions were that if, as you can see here, the curve shows, in this case, like by how much the reaction times are delayed based on the occupation of the global workspace. So you can see that, like the dark red would be like you occupy it for a longer time, and as you go lower, it's occupied for a lower time. And the idea was that if Stan is right and there was no occupation of the global workspace at the offset, then we will see like a flat line, right? Irrespective. So first check for the, let me just go here. For the target, what we observe we replicate beautifully the PRP effect, but in this case there is two tasks. The subjects are responding to the first stimulus visually, and they are responding to the stimulus auditorily. So this is just a check, so to speak. And we see very nicely the patterns of responses, both for at the onset and at the offset, but that's obvious because the subjects are doing a task, right? So this is just to tell us that we are doing the good thing. Now, the interesting aspect comes now only with the task relevant and the task irrelevant, because in this case, they were not doing a task, right? Now we're using the PRP just as a way to see for how long the global workspace is occupied. And we can very nicely see that this happens both for the task relevant and for the task irrelevant, is what you see in red, and there is almost no offset, no indication of offset response. So it seems actually he was right. It seems that the attention was not drawn to the offset, and therefore we should not have expected an offset response in the cogitate experiment. Furthermore, we could in this case also confirm that if you do have longer occupancy of the global workspace, you see that the task, in this case the task relevant condition engaged prefrontal cortex for longer time. This is what you can see in green, and you can see in brown that this is the task irrelevant one. So we can see that in essence, yes, every time the subjects do a task, they occupy the global workspace for a longer time, but if they don't, they occupy it for less, and that's actually, this scales with the PRP response that we had. So this is all to say, I think this is not science as usual. This is an unusual collaboration because we're not trying to say like who is right and who is wrong. We're trying to really make progress in science. And so where are we left at? We need to wait for the next experiment for the video game. We need to wait for the single unit experiment, but we also need to wait for what like Stan and his team and everybody else has been doing, which is accruing data over many decades, right? We just need to now make sure that the experiments at least are on the same ground. That's the important aspect. But I would like to actually leave you with two important messages. So one is that I think that adversarial collaborations can be good mechanisms to advance science because it puts people to speak the same language, but they are not easy. They're not easy on the people, and they're not easy on the funding and on the incentives also. So I think this is something that is very difficult to be replicated. Now, if we do that, I do think that we need to try and understand and have answers to questions such as what happens with islands of activity in vegetative states, what happens with babies, what happens with other species, and what happens with AI. And ultimately what we want is that we want to get the answers right. We don't want to be right. So last, the data is all open, so you can now test whatever you want, and this is something that Stan was always pushing. The most important thing of these collaborations is that the data is going to be out. So this is the Cogitate team, and I will give them a big chapeau, but I think that I could not stop by giving Stan a big chapeau. This is in Seattle back in the day. And I took this picture because to me, this is like we are walking through this moment of we don't know where we're going to end, right? And what we do know is that where we always end with Stan is with these amazing questions that were actually even more difficult than than the whole process, right? And last, I took him this morning because, as I told you, he was this incredible mentor even to me back in Chile 1,000 years ago, right? So I think that he embraces the motto of the Collège de France to teach to all, including those who are not in this room. And I think that this is one of your biggest virtues. And, giving us these 10 questions that, of course, I think that we are not, we are going to make strides, through your brilliance. It's also a big presence. So thank you, Stan.